You ever see a soccer player just launch a ball? It sails in this perfect arc, and you're just like, wow, how'd they even do that? Well, it's not just skill. It's physics. And hidden inside that physics is this surprisingly simple mathematical blueprint. And in this explainer, we're going to crack that code.
So, let's get right into it. How can something like math, numbers and letters on a page, predict exactly where a soccer ball is going to go? Like exactly how high it'll fly and exactly where it's going to land. That's the puzzle, and we're going to solve it together.
And here's the crazy part. That beautiful curve, it's not random at all, not one bit. You see it everywhere. A basketball swishing through a hoop, water shooting from a fountain, even the massive curve of a bridge. They're all secretly following the exact same predictable mathematical pattern.
All right, so what is this secret blueprint? It's got a fancy name, a quadratic function. Now, don't let the name scare you off. The idea behind it is actually super powerful. And you'll see, it's way simpler than it sounds. Okay, so what is it? A quadratic function is basically just any equation where the star of the show is a variable that's squared. Like x to the power of 2. And the cool thing is, whenever you graph one of these, you get this perfect, beautiful, U-shaped curve. It's called a parabola. And trust me, that shape, it's the key to everything. And here it is. This is the blueprint itself. By just tweaking the numbers for A, B, and C, we can map out the path of pretty much any object flying through the air. So for our soccer ball, Y is just its height and X is how far it's gone forward. Simple, right? Okay, let's put this blueprint to work. Time to answer our first big question. You know that awesome moment in a great kick where the ball just seems to hang in the air for a second right at the top? We're going to find out exactly how high that is.
And with this new tool in our pocket, we're not just guessing, forget estimating. We can pinpoint the exact maximum height that ball reaches on its journey. And the math to do it, it's actually way more straightforward than you might think.
So in the world of math, that peak has a special name. It's called the vertex. And for a curve that opens downwards, like an upside-down U, like our ball's path, the vertex is that one single highest point. It's literally the peak of the mountain. And get this, finding it is a super simple two-step process. First, we use this handy little formula to find the horizontal spot where the ball hits its peak. Then, you just take that x value and plug it right back into our main equation. Boom! That gives you the y value, which is the actual height. All right, moment of truth. We've taken the numbers from our kick, we've plugged them into that vertex formula, so how high did it actually go? 12.25 meters. 12¼ meters? Isn't that amazing? This just perfectly shows you the power of this blueprint. We didn't need any fancy sensors or super slow-motion cameras. All we needed was a little bit of math to find the exact peak of that ball's flight. Incredible. Okay, that's awesome. We know how high the ball went. But that's only half the story, right? The other huge question is, where's it going to land? To figure out the landing spot, we have to do something called solving the quadratic equation. Now, solving, in this case, just means we're looking for the distance, x, where the height, y, is back down to 0. In other words, where the ball hits the ground again. So if you just picture it in your head, solving really just means finding the spots where that beautiful arc crosses the ground, the x-axis on a graph. And if you think about it, that curve is going to hit the ground in two places, right at the beginning, where it was kicked, and then that second point, well, that's where it lands. So, this is super important. Let's make sure we've got this straight. Finding the maximum height, that's all about finding the vertex, the very top of the curve. But solving the equation, that's about finding where it hits the ground, the x-intercepts. So two totally different questions, but they're both answered by looking at different parts of that same amazing curve. Look, a soccer ball is a really fun example, right? But the true power of this idea, this parabola, it goes so far beyond a sports field. So why does understanding this one simple shape actually matter in the real world? Because this blueprint, it's one of the most fundamental tools we have. We're talking engineers, scientists, designers. They use this stuff every single day. And not just to understand the world, but to literally build the world around us. Think about it. That U-shape is exactly what lets a satellite dish focus signals perfectly. It's the core shape that gives a suspension bridge its incredible strength. Engineers use this exact math to figure out how much cable they need, saving millions of dollars. It's even used in business to model profits and find that sweet spot for pricing. This shape it's literally everywhere. And that right there is the ultimate point. That's the real power. Math gives us this incredible ability to model the real world. And once you have a model, you can start to predict what's going to happen. And once you can predict, you can optimize. You can tweak things to get the absolute best result possible. Model, predict, optimize. That's the game.
So from now on, when you see a ball flying through the air, or water arcing from a hose, or even look at the curve of a distant hill, maybe you'll see it a little differently. Maybe you'll see that hidden blueprint, that invisible parabola shaping its path. So my question to you is, what other invisible arcs are you going to start seeing all around you?